Okay, so today we're going to be diving straight into some really interesting stuff that just came out. It's a paper announcing something called Cogito V1 Preview.
Yeah.
And it's from this company, Deep Cogito. And, if you're someone who is really following what's going on in the world of AI, and particularly the kind of AI that can actually reason, this is pretty big.
Yeah, it's definitely a pretty substantial development. And I think what makes it especially intriguing for those of you who are building up your knowledge in AI and machine learning is that it's not just about, them releasing new language models, right? It's about the way they're actually training them. It's a totally different approach that they've taken. They're basically proposing that this could be like a major step forward in how we can develop AI that's, really advanced.
Yeah, for sure. And I think, our mission today is to really unpack this Cogito V1. We want to look at what these models are. What can they do? What's this, secret sauce behind the training, this iterated distillation and amplification, or IDA as they call it. And, what does it all mean for the future AI? And the really cool thing is you can actually get your hands on these models right now and experiment with them yourself. They're on platforms like Hugging Face and Allama, and you can even use them through APIs on Fireworks AI and Together AI. This is not just some theoretical idea. This is real stuff that you can go and play with, which is really exciting. Let's jump in.
So, Cogito V1 is actually not just one thing. It's like a whole family of models they've released. They range in size from this sort of smaller one at 3 billion parameters, which is relatively, manageable and efficient, to this much larger one at 70 billion parameters.
Mm-hmm.
For those who are maybe newer to this world, parameters are kind of like the knobs and dials inside the AI, right? That let it learn and store information. And so generally speaking, the more parameters you have, the more complex stuff the AI can handle.
And the performance they're claiming is really turning heads, across, most of the standard ways that we measure how good an AI is, what we call benchmarks. They're saying that these Cogito V1 models are outperforming the best open source models that are the same size. And that includes, some really well-known models like stuff from Llama, DeepSeek, and Quinn. And, here's where it gets really interesting. Their 70 billion parameter model is actually claiming to do better than Llama 4's 109 billion parameter mixture of experts model, which is like saying, a smaller engine is outperforming a bigger, more complex one.
Right. It's a great way to put it. And just to quickly explain, these mixture of experts models, they're typically larger because they're combining multiple specialized AI brains within one model, so they can be good at lots of different things, right? And the fact that Cogito V1 is getting better results with fewer parameters suggests there's something really efficient about their training approach. Another fascinating thing is that these models have this sort of dual nature. They can just answer questions directly. Like most language models you might have seen, you ask it something, it gives you an answer, but they can also self-reflect before they answer, which is something we typically see in AI that's specifically designed for reasoning. It's almost like the model is taking a moment to think through the problem before it gives you an answer.
Yeah, it's got a little bit of that, internal dialogue going on, which is really cool. And they're not stopping there. Deep Cogito is saying they're planning to release even bigger models down the line. We're talking 109 billion parameters, 400 billion parameters, and even this massive 671 billion parameter model, which is just kind of mind blowing. And on top of that, they're promising even better versions of the current models that are out there now. They've also really focused on fine-tuning these Cogito V1 models for specific kinds of tasks, like, writing code, being able to use external functions, which basically lets them interact with other software, and also for building more sophisticated AI agents. Those are those AI systems that can actually perform actions and kind of, operate more autonomously.
Right. And it's worth noting that, while a lot of the really advanced AI development right now is focused on making models that can do these super long and complex chains of reasoning, Cogito V1 isn't really optimized for that particular use case. It seems like they're more interested in this kind of broader, more efficient approach to reasoning.
Gotcha. So we've got these powerful models, some pretty impressive claims, about their performance. But the paper isn't just about getting better scores on some leaderboard. It's actually talking about something way bigger. This idea of the path to general superintelligence. And, for anyone who's maybe still wrapping their head around what AI is all about, superintelligence refers to this, hypothetical point in the future where AI actually surpasses human intelligence across almost all areas. It's a pretty profound concept.
It really is, yeah. And, Deep Cogito sets up their work by looking back at some of the big breakthroughs in AI, AlphaGo, the AI that beat the world champion in the game of Cato, right? These systems showed us that AI could actually achieve superhuman performance in certain areas through advanced reasoning and, crucially this process of iterative self-improvement, which means they could learn and get better without humans having to step in and guide them at every single point.
And that brings us to what Deep Cogito sees as the limitations of how we're currently training large language models. With smaller models, a lot of times they learn by being distilled from bigger, more capable models. It's kind of like a student learning from a teacher, right? The student's understanding is limited by what the teacher knows. So those smaller models are basically capped by the intelligence of the bigger models they're learning from.
Right. And even for those really massive cutting edge models that we have today, the ones that are trained on tons and tons of data that was created by humans, there's still this kind of bottleneck that, these models in a sense are limited by the collective knowledge and intelligence of all the humans who put together that data and kind of guided the training process.
Yeah.
So Deep Cogito is arguing that to get to true superintelligence, we need to find a way to break through these limitations.
Oh, and this is where their solution comes in the really innovative part, and that's what they call Iterated Distillation and Amplification, or IDA. They're saying this is a more scalable and efficient way to develop general superintelligence because it's not ultimately bound by the limits of human intelligence. So let's break down how this IDA thing actually works.
Okay, so at its heart, IDA is basically this cycle, with two main steps that get repeated over and over again. The first step is what they call amplification. And this is where they use a lot of computational power to generate what they describe as higher intelligence capabilities, like giving the model extra brain power, some additional tools to solve problems in ways that it couldn't before.
Right. They give some examples of these, really computationally intense methods. One of them is this thing called chain of thought reasoning, where the model actually, shows its work, it shows its thinking steps, which makes it easier to spot errors and correct them. Another one is having the model kind of check its own answers or even generate multiple different answers and then pick the best one. And all of these things require more processing power than just doing a single straightforward calculation.
Exactly. And then the second step is what they call distillation. And this is where the enhanced intelligence that the model gained during the amplification step is kind of transferred back into the core of the model, into its parameters. The model learns to internalize the improved reasoning or problem solving skills that it developed through those more computationally intense processes. You can think of it a student who's using a tutor to understand a really difficult concept, and then eventually they're able to solve similar problems on their own without the tutor's help.
Right. So it's the model goes through this really intense learning phase with these extra resources. It figures out a better way to think, and then it somehow hardwires that improved thinking process into its own structure. And the key thing is that this isn't just a one-time thing. It's this ongoing cycle of amplification and distillation.
Exactly. And that's where the positive feedback loop comes in, right? Each cycle builds on the progress made in the previous one. Mm-hmm. So the model is getting smarter and smarter, and the thinking techniques it uses during the amplification phase are also getting more and more advanced over time, and that's how they're trying to go beyond those initial limitations of the data and oversight provided by humans. The capabilities are increasingly driven by the computation and this IDA process itself. It's that student who learns a little bit then uses that knowledge to learn even more effectively, and that improved learning helps them learn even faster in the future. Yeah. It's like a snowball effect of intelligence. That's a great way to put it. And Deep Cogito is claiming that IDA has some big advantages. They say it leads to consistently better performance, that it can be applied to all sorts of different tasks, and that it's actually more efficient in terms of time and resources compared to some of the other common methods for training AI, like reinforcement learning from human feedback, or RLHF, where you're using human feedback to directly guide the model's learning, or even just training these massive models on mountains of data.
Yeah. And to give you a concrete example of this, Deep Cogito points out that their Cogito models were developed by a pretty small team in just about 75 days using this IDA method. And they highlight again how their 70 billion parameter model is outperforming both Llama 3.3's 70 billion parameter model, which was distilled from a much larger 405 billion parameter model, and Llama 4 Scout's 109 billion parameter model, which was distilled from an even bigger model, a 2 trillion parameter model. So, that really emphasizes how efficient their approach could be.
Yeah, it's pretty impressive. And when we look at the Cogito V1 models themselves, the paper mentions that they started with these existing pre-trained base models from Llama and Q, so they weren't building everything from scratch. And they've really honed in on optimizing these IDA trained models for things like coding, using external functions, and, for building those AI agents, those more autonomous AI systems that can actually interact with the world around them.
Right. And they also reiterate that each Cogito V1 model has these two modes of operation, the standard mode where it answers questions directly, and then the reasoning mode where it takes that extra step to kind of think things through before it gives a response. And it's interesting, they point out that they haven't specifically focused on making it really good at these super long and complicated chains of reasoning, which might make it different from some of the other cutting edge reasoning models out there.
Makes sense. Makes sense. So, of course, whenever a new model comes out with these bold claims, everyone wants to see the proof, right? So Deep Cogito has this whole section in their paper where they talk about how they evaluated their models. They compared their models to other leading models that are similar in size, both in that direct answering mode and in the reasoning mode. For direct comparisons, they looked at these instruct-tuned versions of Llama and Quinn. And for the reasoning comparisons, they used DeepSeek's R1 distilled models and Quinn's QWQ model.
And, as is standard practice in the field, they used a bunch of well-established benchmarks to show how effective their IDA training is. These benchmarks are basically like standardized tests. They're designed to measure how well a model can do different kinds of tasks. But they also include this really important disclaimer that anyone looking at benchmark results should keep in mind.
Yeah, they really emphasize that while benchmarks can give you like a quick snapshot of what a model can do, they don't necessarily tell you the whole story about how well it will perform in the real world or how well it will meet the specific needs of a user. Mm-hmm. They even say that benchmark scores only loosely correlate with actual usefulness. But having said that, they do state that their models have done really well across a bunch of these well-known evaluations, which makes them confident that they have real-world potential.
Yeah, and they're careful to point out that they made sure to exclude the data that was used in these benchmark tests from the data that their models were trained on. So it's really important to make sure that the performance they're reporting isn't just because the model memorized the answers. Another interesting point they bring up is about tool calling, which is the ability of a model to actually use external tools and software. And they noticed some improvements in this area with their Cogito models, especially in that smaller 3 billion parameter model compared to Llama 3.2's 3 billion parameter model, which doesn't have that capability built in. But they acknowledge that some of these improvements are probably due to specific techniques they used after the training was done to make the models better at tool calling rather than being solely a result of the IDA method itself.
Right. And they also talk about these things called live bench scores and live bench global average as additional ways they've been evaluating their models. So it seems like they're really looking at a wider range of metrics beyond just the typical academic benchmarks.
Yeah, definitely. And looking ahead, Deep Cogito's clearly very excited about this iterated distillation and amplification as a way to achieve self-improvement in AI.
They point out that they're really just starting to scratch the surface of what's possible with this approach. And they've only used a tiny fraction of the computational resources that are typically used for training the biggest language models, which suggests that there's a lot of room for improvement just by scaling up the computational power used in the IDA process.
That makes sense. And they're also actively exploring other techniques that they could use after the main training is done to further enhance their model's capabilities. And they've announced that we can expect updated versions of all their current model sizes soon, with longer training periods, and also those bigger models, the 109 billion, 400 billion, and 671 billion parameter models in the near future, which is pretty exciting. And importantly for the AI research community and, folks like you who are interested in this stuff, they've confirmed that all of their models will be open source. So that means that the models and the technology will be publicly available for anyone to use and experiment with, which is a huge contribution to the field.
Yeah, absolutely. And bringing it back to their overall goal, Deep Cogito is pretty upfront about the fact that they're aiming to build general superintelligence. And they believe that to do that, we're going to need some fundamental scientific breakthroughs in areas like advanced reasoning and iterative self-improvement. It's not just about replicating human abilities. It's about potentially unlocking entirely new forms of intelligence.
Right. And for some context, they're based in San Francisco. They've got funding from some big names in the AI investment world, and they're actually actively looking for talented people with expertise in LLMs and AI infrastructure to join their team. They even put a call for applications in their paper. And to wrap things up, they acknowledge the contributions of all the different teams and open source projects that have helped them along the way. It's a real community effort.
So just to bring it all together for you, our listener, this deep dive into the Cogito V1 preview has shown us this new family of high-performing open source large language models. And what makes them really stand out is this unique training method they're using, this Iterated Distillation and Amplification, or IDA. And this method is all about trying to overcome the inherent limitations of how we've traditionally trained AI by creating this continuous cycle of self-improvement that's driven primarily by computational power rather than being completely reliant on human-provided data or direct oversight.
And for those of you who are, beginner to intermediate learners in AI and machine learning, this work is especially important because it presents a potentially new path towards more advanced AI, and it provides accessible models that you can actually use to experiment with these cutting-edge ideas firsthand.
Yeah.
It really highlights the power of thinking differently about how we train AI, and it suggests that the future of intelligence might lie in these iterative, self-driven learning processes.
And that leads us to a final question for you to ponder, given, the early promise of this IDA approach and the clear emphasis on computation as this driving force behind AI self-improvement. What are the long-term implications of a future where AI development is increasingly shaped by these scalable, iterative techniques, potentially with less direct human guidance in the learning process itself? It's a really big question with no easy answers, but it's a question that becomes more and more relevant as this field just keeps advancing at this incredible pace. So yeah, thanks for taking this deep dive with us.
Thanks for listening, everybody.
Appreciate it.
See ya.